So what's the Doppler effect got to do with the expanding universe, you might be asking? Well, it all goes back to the work of this guy almost 100 years ago, Edwin Hubble. He made thousands of observations of galaxies, distant stars, and he noticed something very, very important. Okay, he noticed that all the light seemed to be redshifted. Right, let me explain what redshift is. Okay, the Doppler effect we've seen with sound, but the Doppler effect is something that happens with all types of wave. It even works with light. Okay, now as we know, visible light, white light, can be split up into all the colors of the visible spectrum, starting with red at one end of the spectrum, all the way down to violet at the other end. Okay, what's the difference between these colors though? Right, well, it's all about frequency and wavelength. Just like pitch, high pitch and low pitch with sound, you can have high and low frequency with light. It's exactly the same concept. Now, the way it works is your red color is the low frequency, and the violet color is the high frequency. Now, the frequency will increase as you move through the visible spectrum from red to violet. That's the only difference between colors, is the frequency of the light. Now, if the frequency is different, then so is the wavelength. Now, can you remember how it worked with sound? If you have low frequency, you have long wavelength, don't you? Okay. And at the other end of the spectrum, if you have high frequency, then you have short wavelength. Okay, so that's the difference between the two ends of the spectrum. Red has a long wavelength, and violet has a short wavelength. Okay, just like high pitched and low pitched sounds. Okay, but what did Hubble observe? Well, like I said, you get the Doppler effect with light just in the same way you get the Doppler effect with sound. Now, here's the important bit. If a star or a galaxy is moving away from the observer, then the light that reaches the observer will be stretched. Okay? Just like the animation we saw with the bee. The sound wave, remember the sound waves get stretched out? It's the same with light. If the wave source is moving away from the observer, the waves get stretched out. Now, if they get stretched out, the light will be shifted towards the red end of the spectrum because red is a longer wavelength. Conversely, if the star or the galaxy is moving towards us, the waves get bunched up, they get squashed together, and as we know, blue and violet has a shorter wavelength, so the light from the star will look more towards the blue end of the spectrum. Now this one here, this is called redshift. So if the light is redshifted, the star or galaxy is moving away. If the light is blue shifted, then the star or galaxy is moving towards us. Okay? Now, what exactly did Edwin Hubble observe? Well, this is the important bit. He observed that pretty much every galaxy and star, the light is redshifted. So if we were to say we were in the Milky Way, say here, say that was the Milky Way, and Edwin Hubble is sat somewhere in the Milky Way 90 years ago, looking at all these other galaxies through his telescope. Okay. Now, if the light is all redshifted from these galaxies, the only conclusion is that all these galaxies are moving away. Okay, they must all be moving away from us. Now, if they're all moving away from us, It's because the whole universe is expanding. Now, last video for you today is to watch this. This is where I model that. Okay, just a short video where I'm going to model the expanding universe to show you why the conclusion was made that the whole universe is expanding. Okay, thank you very much for listening. See you in the next lesson.